Hello, today's lesson is on proportional relationships and graphs. And please pay attention to this new section on our notes where you need to know what supplies you will need for this lesson. So you are going to need your agenda or your planner, graph paper, a ruler, and a pencil. So go ahead and pause the video now and go get those things if you don't already have them. And then once you have your agenda or your planner, write your learning target in for today. So you're going to write, I can use graphs to represent and analyze proportional relationships. Okay, and if you don't want to write that full sentence, you can just say graphing proportional relationships. Okay? All right, so then once you have that in, we are going to review one more time the definition of a proportional relationship. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. And remember that we represent that constant with the letter A in our formula y equals A times x. All right, so here's our first example. A showerhead uses 5 gallons of water per minute. We've already been working with problems like this, so you should be set on how to solve this problem. Here is our table that represents this information. So on top we have time, and underneath we have the water used in gallons. And so in 1 minute we have 5 gallons. This table is asking us to fill in how many for 2 minutes. Well, in 2 minutes we know that if we're using our formula, y equals A times x. A, our constant, is the 5 gallons per minute, 5 over 1. So 5 times x, and the x is the changing variable, so the time in this case. So 5 times 2, so the water used is 10. 3 would be 3 times 5, which is 15. And then this question mark up here is asking you how many minutes go by when it's using 35 gallons of water. So this time it's telling you the y. So it's telling you y equals 5 times something. So this is just a division problem, and you can figure out what that's going to be and go ahead and write it in this box. And then the second question is asking you, is this a proportional relationship? And remember, for a proportional relationship to be a proportional relationship, you have to be able to write the constant as a ratio over 1. So in this time it's saying 5 gallons of water per minute, so 5 over 1. And then we have to look, does that hold true for all of these minutes and all of these gallons? And yes, it does. So this is a proportional relationship. You just write yes. And then the common ratio we've already talked about twice now is the simplest form of all these numbers. So 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. And 35 divided by the number you get up here should also be 5. So guess what your common ratio is? 5. All right, so now that we know all of this, the new information that we're learning today is how to apply all this information into a graph. So you will need graph paper, and I prefer that you use a pencil and a ruler to make sure that your lines are straight. And let's go ahead and look at how to do this. So basically, when you have your table up here, your time is always going to be x, and the amount or whatever substance you're working with is going to be y. So now that we can see these as either x and y or xy coordinates, we can graph them. So we know that at 1 minute there was 5 gallons of water. So our first coordinate is 1, 5. And then our second coordinate here is 2, 10. Our third coordinate is 3, 15. And if you're confused, I'm just grabbing these coordinates from right here, 1, 5, 2, 10, and 3, 15. So your fourth coordinate would be that number that you found as the x, and then 35. So I'm going to write a question mark and 35, but you'll write the actual number that you found here. All right, so now we've got 1, 2, 3, 4 coordinates, and we can really easily graph them on this graph or on your own graph paper, your choice. So I'm going to go over 1 and up 5. Here's my first coordinate. And then 2, 10. Well, this coordinate plane only goes up to 7, so I'm going to have to estimate. Here's 2, 7, so 8, 9, 10 would be about here. And 3, 15, same thing. We're going to be going pretty high up here. And if you're doing this on your own graph paper, you can draw a more precise graph. And this one goes up to 35. I'm not even going to try that. It'd probably be off the page. So once you have 3 coordinates, my minimum is for 3 coordinates anytime you're doing graphing. Start with the first coordinate and draw a line through all of your coordinates. Please make sure it's straight. And then, because this is a proportional relationship, we need to make sure that we have arrows at each end of our newly drawn line. And by arrows, I just mean one of these and one of these, just like that. Okay, and these arrows mean that this line goes on for both directions for infinity. So we could find out how many gallons are used for 4 by looking at this graph, and how many are used for 5, and just keep going from there. All right, and then the next question that I have for you is actually in a part of our practice questions that we have at the bottom. And my question is this: would the line go through the origin? Why or why not? And I'm asking you to write 2 sentences on that. So they're asking you, I'm using purple now, they're asking you if the blue line that we originally drew would go through this point right there. And if so, why? Or if not, why? So basically, let's figure out what this point 0, 0 represents. So if we go back up to our table, 0, 0 would be right here. We'd have 0. So in 0 minutes of using the shower, how many gallons of water were used? Well, 0. So using that information, would this 0, 0 origin be a part of the proportional relationship that we just graphed on the XY coordinate plane? So it's going to be either a yes or no, and then I'm asking you to explain why. And then on number 2, this one is saying that another shower head, maybe another brand, uses less water per minute, and it's asking how would its graph compare to this one above. So how would the graph of a shower head that uses less water per minute compare to this blue line that we drew up here? I want you to at least write 1 sentence to explain that, and then I also want you to draw a sample line that would show where the new line would compare for a different water or for a different shower head. So it could be going down this way, it could be coming up from over here. You're going to have to tell me where it's going to be and then explain to me why. And then number 3 is the same exact type of problem that we did up above. So if you struggle with number 3, please go back and watch this video again to figure out how to solve number 3. But it's saying that an internet cafe charges a one-time $5 service fee and then $2 for every additional hour of use. So they're saying, is this relationship a proportional relationship? If so, fill in the table and then complete the graph on the back of this paper or on your own graph paper. So here's the graph that I provided, or the table that I provided. And let's take a look at that real quickly, because it's saying a $5 service fee. So anyone who uses the internet at least once in that cafe has a $5 service fee, and then they get charged $2 for every extra hour of use. So for 1 hour of use, the common mistake on this problem is to write 2 here because they only spent 1 hour, and so it's $2 for every hour of use. But we also have to remember that there's this one-time service fee that's going to apply no matter how long they use the internet. So here's 1 hour, and the total cost was $7 because the $5 service fee plus the $2 for that hour. So 5 plus 2 is 7, and that's what they got. All right, and then let's do 2 together. 2 would be for 2 hours, so $2 for every hour of use, so that's $4, plus the $5 service fee, so 4 plus 5 is 9. So this, for 2 hours of use, it would be $9. All right, so you go ahead and fill in how much it would be for 5 hours, how many hours you get for $17, and then how much it would cost for 8 hours of use. And these aren't zeros, these are boxes that you need to fill in. Okay, once you fill in those tables, tell me, is it a proportional relationship? And if so, graph this on the back of this paper, on your notes, or on your own graph paper. My hint to you is on this column right here. A relationship is proportional if it goes through the origin of a graph. So if we're looking at just any origin or any graph right here, that's a sloppy graph, but if we're looking at it, we can look and can you tell me instantly if this line is proportional? Yes, because it goes through the origin, so we can say for sure that this line is proportional. What about a line like this? Let me change my color. What if it was a line like this? Well, yes, it still goes right through the origin, so even the pink line is proportional because it passes through the origin. So if you're ever taking a test or a quiz and it asks you to look at a graph and it doesn't give you any information, but it just asks if this is a proportional relationship, you can tell by whether or not it goes through the center 0, 0. All right, so go ahead and complete your 3 questions at the bottom of this page, and then come to class tomorrow with these notes completed. And then please don't forget to bring your planner as well so I can check that you wrote in your learning target. All right, I will see you soon.